This is Math 2, 10.3 notes. That's Math 2, Unit 10, Lesson 3. At this point, all of you should have this worksheet out in front of you, as well as a calculator and something to write with. Okay, we are doing homework notes today, which means we're going to just do a few problems together off of the worksheet for our notes. All right, first one. A golfer hits a ball from the fairway to the green. The flight of the ball is modeled by the equation, and here's the equation here, which we've seen these type of equations before, where x is the time in seconds. Since the ball was hit, x is time in seconds, and g of x, which is the y-axis, is the height of the ball in feet. Okay, so we're going to sketch this. So today what we're doing is we're going to see applications to these quadratic functions that we've been dealing with the last few days. And I told you guys when we deal with them in word problems form is when the domain is going to change. So far it's been all real numbers. It's going to change today. Okay, add labels to the axis including variables, descriptions, and words, and units. All right, so here it says x, this is the x-axis. X is time in seconds, so I'm going to label down here my x-axis is time in seconds. And g of x, this g of x is the y-axis, is the height of the ball in feet. So I'm going to label over here, this is height in feet. Okay, focus on the equation used to model the ball's flight. What will the graph look like? Be as specific as possible. Okay, we've talked in the past, since it's negative, we know it's going to be opening down. What else do we know? We talked about opposite of the inside, outside stays the same. The inside is right, left, and since it's opposite, it's going to translate right to, and plus 64, outside stays the same, and that's up, down. It's going to translate up 64 units. So right 2 units, up 64, which means our vertex is going to be positive 2, positive 64. Okay, what is the height of the ball at 0 seconds? Now, it would make sense at 0, but sometimes balls start with a specific height. They're not shooting out from the ground. Sometimes they are treated as if they're shooting out from the ground, but sometimes they're launching from a platform, so they have a specific height. So let's see what the height is at time 0. I'm going to change g of x to y, negative 16, and I'm plugging 0 in for x. So it should look like this when you write it down. Negative 16, parentheses, 0 minus 2 squared plus 64. Okay, so I'm using this equation right here, and I'm just plugging in 0 for x. Order of operation, I do what's in the parentheses first. And then we talked about this in class a few times. Order of operation, you square before you multiply by the negative 16. Negative 2 times negative 2 is positive 4. And then plug in your calculators, negative 16 times 4. It's negative 64 plus 64, so y equals 0. Remember, y is the height. So at time 0, the height is 0. So it is being treated as if it's being launched from the ground level. Okay, scale each axis, so all the important features of the graph will show. Graph the parabola. Okay, my vertex is going to be right 2 up 64. So it makes sense here to count by 1s. I don't have to count by 5s or even count by 2s because 2 is going to fit on there. So I'm going to label 1, 2, 3, 4, 5, 6, 7, 8, 9. I am counting by 1s, but I'm just labeling every other to space it out just a bit. Okay, now it would not make sense to count on the y-axis by 1s because I have to get up to 64. So let's check if 5s would work. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Yes, it would work. So I am going to count by 5s. But again, I'm going to label every other. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay. All right. So vertex is right 2. I know these lines are a little hard to see, but do the best you can. Up 64, which would be right below the 65. And we know it goes through 0, 0, and it's opening downward. And because I know there's symmetry, I know there is an axis of symmetry right here. It always goes through the vertex. So this is x equals 2. Now, because of the symmetry, I know then my next x-intercept, if it's 2 away from the axis of symmetry to the left, it'll be 2 away to the right. So it's going to come back down there. All right. So the ball goes up, up, up. It comes down, 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 which makes sense. The ball does not go up forever. It is going to travel upward, reach its max height, and then travel on its way downward, which makes sense that it is the shape of a parabola. The flight of this ball, as time passes by, it gets higher and higher and higher and higher, reaches its max height, and then comes down, 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 and hits the ground. Hits the ground, height is 0. Okay, so we've already scaled each axis, we put all the important information, we graphed it. Why does it make sense that this graph is only in the first quadrant? Notice I only graphed in the first quadrant. I did not continue like we usually do with arrows, like we have in the past few days. Why is that? Think about why we are only in the first quadrant. Why did I not go negative on the x-axis or negative on the y-axis? Think about it and write something down. Okay, now I'm hoping you came up with something along the lines of, if I went on the negative x-axis, that would be negative time, and there's no such thing as negative time. And if I went negative on the y-axis, that would be negative height, no such thing as negative height. So that's what I'm going to write down. No negative time, no negative height. Okay. Use your graph to identify the domain and range that makes sense for this problem. Okay, so domain and range is going to change a bit from what we're used to. Remember, in the past, domain has always been all real numbers, and I said it would be until we get to the word problems. Okay, now the reason it's not all real numbers is because of this. There's no negative time, there's no negative height, so I'm not going right and left forever. Remember, the domain is a set of all x values. So what x value does it start at? 0. What x value does it end at? 4. So my domain is between the x values of 0 and 4. So we would say x, I'm going to write it on the side, then I'll put the final answer on the answer bar. X is greater than or equal to 0. That's here. Everything greater than or equal to 0. And at the same time, it has to be less than or equal to 4. So my domain are all the values that are bigger than 0 and less than 4. So 0, 1, 2, 3, 4, and all the decimals included within that domain. Okay, so how do we write that here in interval notation? X is sandwiched in the middle. Now x is sandwiched between, because look at this and, is sandwiched between these two numbers. So as long as your smaller number comes first and your larger number comes second, your inequalities will always open up this way. So whenever you're doing these sandwich problems, whether x is sandwiched or y is sandwiched, smaller number to the left, larger number to the right, and they're always going to open this way, less than or less than equal to. Okay, why is that? Look at here. It's opening the other way, but x comes first. X is bigger than 0 is the same as saying 0 is smaller than x. X is less than 4, and that's here. X is less than 4. All right, range. Range, does the graph go up and down forever? Well, the range for us never went up and down forever. It went in one direction forever, but it doesn't even do that this time. It's sandwiched between 0 and 64. And how do I know that's 64? Because that's my vertex, 264. So x is greater than or equal to 0, and at the same time it has to be less than or equal to 64. So now we're using y. We've talked about that before. And I put x. I apologize. That should be a y. We've talked about that before, that range is always the y values. Domain is always the x values. So smaller number to the left, larger number to the right, and always less than equal to when you're writing these sandwich problems. Okay, answer the following questions based on the flight of the ball. What is the maximum height of the ball? Can you see where it's going up, 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 up? It reaches its max height. Now, what is the max height, the 2 or the 64? 2 is time, 64 is height, so it's 64 feet. 64 feet is the maximum height of the ball. How do you know? We just said it, it's the maximum height of the ball. I'm going to put the maximum value because we have talked about that in class. The maximum value is 64. Looking at the graph, put an arrow. Looking at the graph, the maximum value is 64. How high is the ball after 3 seconds? Okay, before I answer that, it never asked in this particular place, but it will ask eventually, how long did it take to reach its max height? The max height is 64 feet. How long did it take? 2 seconds. It didn't ask that here, but it will eventually. The max height is 64 feet, and it took 2 seconds to reach that maximum height. Okay, how high is the ball after 3 seconds? So we're just going to plug in 3 for x, because time is the x-axis. We're going to plug in 3 to x to the original function and see what we end up with. I'm going to try to estimate it, 3, and just come up to your graph. It looks close to about 54, 55, but we're going to plug it in and see. Okay, because we can plug it in and get exact values. Again, I'm changing g of x to y. I'm using this function here, negative 16 parentheses, and for x I'm plugging in 3 minus 2, close parentheses squared, plus 64. Okay. Y equals, order of operation, inside of the parentheses first, 3 minus 2 is 1, squared plus 64. Second step in the order of operation, you square before you multiply. Exponents before multiplication. So negative 16 times 1 plus 64. Y equals negative 16 plus 64, because negative 16 times 1 is negative 16, add those together, and you get positive 48. Y is 48, so 48 feet. So I was a little off, but again, that was using a graph that was roughly sketched. At 3 seconds, it's 48 feet. Makes sense that it's not higher than 64, because 64 is the maximum height. At 3 seconds, the ball's already on its way back down to the ground, so it's at 48 feet at 3 seconds. Okay, let's try another one. Let's flip over to number 2. A peach tree produced 275 peaches per tree when 25 trees are planted per acre. For each additional tree planted per acre, the number of peaches a tree produces decreases by 5 peaches. The function is represented by this function there, where x is the number of trees per acre, and p of x represents the total number of peaches per acre. A lot of words in this problem. Okay, so let's pretend that this is 1 acre. And it says 25 trees. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And imagine all those trees in there. Okay. And if you plant 25 trees per acre, what does it say? You're going to produce 275 peaches per tree when 25 trees are planted. Okay, so you would know if you plant less, you're not going to get as many peaches overall because you're not planting as many trees. And now you would think planting more would give you more peaches. The more trees you plant, the more peaches you would receive. But why does that not make sense? In 1 acre, if you plant too many trees, what's going to happen? they're going to be fighting for resources. They're going to be trying to get the food. There's not going to be enough soil, food, nutrients for the trees, so they're not going to produce as many. So that's why they hire these people to come in and come up with these equations to figure out what's the best. Okay, so preparing the sketch. Add labels to the x-axis including variables, descriptions, and words, and units. Okay, it says here x represents the number of trees per acre. All right, so I'm going to put it down here. Number of trees per acre. P of x, this is the x-axis. P of x is the y-axis, represents the total number of peaches. Total number of peaches per acre. Okay, I'm going to space that out a little bit because I'm going to putting some big numbers in there. So I'm going to space it and put here peaches per acre. All right. Focus on the equation used to model the total number of peaches. What will the graph look like? Be as specific as possible. So again, because it's negative, we know it's opening downward. What else do we have? Opposite of the inside, outside stays the same. Inside is right, left, so it's going to translate to the right 40 units and then translate up 8,000 units. So the vertex is going to be 40, 8,000. All right. How many peaches do you expect? So this is predicting. How many peaches do you expect if 0 trees are planted? If we plant no trees whatsoever, would you expect negative peaches, no peaches, or a few peaches? We would expect no peaches at all because you're not planting any trees. So 0 peaches if no trees are planted. That makes sense. Now, what does the function predict? So now let's actually plug it in and see if our prediction, our expectations were correct. I'm going to change P of x to y, -5, and I'm going to plug 0 in for x. I'm plugging it into this function here. 0 in for x, and then minus the 40, quantity squared, plus 8,000. All right, order of operation inside the parentheses first. That gives me -40. Go ahead and plug in your calculators. -40 times -40. You get 1,600. And then multiply that by -5. Gives you -8,000 plus +8,000 is indeed 0. So this is 0 peaches. Once again, we predicted, we actually calculated it. If you don't plant any trees, you're not going to receive any peaches. Okay, scale each axis so all the important features of the graph will show, and graph the parabola. Okay, so let's space this out. 40 is, I'm going to translate to the right 40, which means I'm not going to count by ones. Let's see if 5s would be enough. 5, 10, 15, 20, 25, 30, 35, 40. It looks like it'll be enough. I'm going to count by 5s but label every other so I have room. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, and I'll see if I need to label more as we go. Okay, here I need to get up to 8,000. So I'm going to give you guys a few seconds to figure out what to calculate by. Definitely not by 1s or even 2s, even 5s. Hundreds, 500s. See what's the best to count by. I'll give you guys a few seconds. Remember, we're trying to get up to 8,000. All right, I'm hoping you figured it out. I'm going to count mine by 500s. I'm going to label every other, but I'm counting by 500. So the first one's 500. 500 and 500 is 1,000. 1,500, 2,000. 2,500, 3,000. 3,500, 4,000. 4,500, and then 5,000. 5,500, and then 6,000. 6,000. That looks weird. 6,500, 7,000, 7,500, and 8,000. Okay. Now, I'm going to have you finish the rest off on your own. Go ahead and plot your point right for 40, up 8,000. We know it's opening down. We know 0, 0 is a point because when we plugged in X for 0, we got Y as 0, so we know that's a point. And what else do we know? Let's see, 40 up to 8,000. And we know symmetry. 1, 2, 3, 4, 5, 6, 7, 8. So we're going the other way as well. 1, 2, 3, 4, 5, 6, 7, 8. So we have to count up to 80 to get our other x-intercept. Okay, so go ahead and draw your parabola and then answer the remaining questions.